Alright, hello everyone, this is just going to be a, hopefully, pretty quick video about how we can utilize variables and conditionals in JavaScript and P5 just to measure the boundaries of some very common shapes and then use that to create some interactions. And these interactions can be as basic or as advanced as you want them to be. So, towards that goal, I've got just basically the default P5 sketch up here. Um, I've just made the canvas a little bit bigger so I have some room to work with stuff. So there it is. Uh, the first thing I'm going to do is start by making a rectangle. I'll start with that's a little bit easier. So to do this, I'm going to highly recommend that you create your shape with variables. It's going to make it a little bit more easier to see what's going on, and then you also have the ability to adjust your shapes and change them and still have your interactions work. So let's see, x equal equal I'm extra space there, and let's just say 200. So I've got the variables right there, and I'm gonna set this up. I'm first gonna say fill. I'm just gonna make this blue, nice and easy, and then a rectangle, and it's gonna be that's the rectangle X position, the rectangle Y position, the width of the rectangle, and the height of the rectangle. Boom, there it is. Actually, I'm going to adjust this a bit and make that 150, just so I have room to put the circle down here. So there is the first part. We have our shape that we want to measure the boundaries of. Now, you don't have to have this drawn with variables, but I think it's going to make it a little bit more clear to see exactly what we need to do. So I'm going to set it up so whenever I click on the mouse, something happens. All right, so to do that, I'm going to start off with a nested conditional statement. If the mouse is pressed, we're going to do something. What that something is going to be checking to see where the mouse is located. We only want something to happen if the mouse is pressed over this rectangle. Okay, so to do that, we can just nest inside if, another one. We say mouse X is greater than rectangle X. I'm sorry, I got that backwards. That should also be there, and greater than. Then we're gonna do some stuff. All right, so again, this rectangle X position is right over here, this boundary of the shape. We wanted to see if mouse X is bigger than that. So that's the first one. You can do this several different ways. You can do more nesting. You could have multiple conditions. I'm just going to list them out right here. And mouse X is less than, and this is where some math starts to come in. So we want to figure out, is it less than the other side of the shape. We can't just say, however, rectangle width, because, well, first of all, they're the same, but the rectangle width is a 100 pixels offset from the rectangle X position. So we have to say instead rectangle X plus rectangle width. And there you have it there. The next thing we want to add in is checking the vertical position. Actually, let me just let's just leave it as it is right now. And let's just say, I'm just going to pick the background, and I'm going to make this green. Great. There's my thing. So, if I click on the square now, that's great. However, we get a little bit of an issue. It's if I click within these horizontal boundaries, but it's not bound to the top yet. So if I click here, well, that's no good. We only want the background to change when we click only on this rectangle. So that's why we have to add in conditions for the top and bottom boundaries as well. The easiest one is just like we did before. If mouse Y is greater than the Y position of the rectangle, now nothing happens when I click over here. Nothing happens when I click over here. Nothing happens when I click up top. But now I need to add in the bottom, and it's going to be just like we had over here. So, and if mouse Y is less than the rectangle Y position plus the rectangle height, now this condition right here, this test where the result is set the background to green, will only be true if we click inside of the rectangle. I'm clicking a bunch as I move my mouse around. Nothing's happening, but as soon as I click inside the rectangle, you see that it changes to green. I'm going to make that a lime green, just to change things up, make it a little less aggressively green. I'm also going to put drawing the shapes after my conditional, so now we can still see the shape over the background. So there we have that. So again, I mentioned that by doing this with variables, we can now change and update everything here. So, and still have everything work. So let's just say if rectangle X, let's make it move down actually. Rectangle Y is greater than height. Rectangle Y gets assigned negative, we start at 50, it's a height of 200, negative 200. So got that there. We can just add in rectangle Y plus plus plus. So now my shape is moving, and we should see, actually I'm going to make it move a little faster just to make it save time. Plus equals 5. So now we have here, we should see it, yep, looping like that. I'm just going to keep clicking my mouse. You see, it only works while we are over the shape. That's a very useful tool because we are changing the variable here that we're using to draw the rectangle, but we're also running the test with those same values. So as rectangle Y changes, we're affecting the shape and the test by the same amount, so it all lines up. If I was to change that and just say, let's say, rectangle Y, down here, if I said this instead and just made it 300, that's not what I wanted. That's 300. Let's just comment that out for now. We get a little bit of weirdness going on. So you'll notice, just like before, I'm clicking on the shape, nothing's happening. But I'm clicking on the shape now, and nothing's happening. But if I move my mouse back up to where we were, now it's clicking. It's clicking over the same position the rectangle originally was in. So again, we're this test to, adjust, in this case, it's just changing the background, but it can be whatever you want it to be. This is just a very simple example. It could be, spawn some new characters, rotate things, do a bunch of processing, run other functions. It can be whatever you want it to be, but just whenever you click on the shape. This is independent of the shape. They are not connected at all, and I want to stress that. Later on, we'll be making objects and classes in this course, and that will be able to tie the interaction to the shape. But right now, these are two different things, two independent things that happen to be lining up. So again, by setting this back to rectangle Y, now it all lines up. You notice the square jumped back up to where we were, and if I put this back here, it will work how you would expect it to. So that's that one. So now let's go in and make the circle. The circle can be a little more complex, but when you break it down, it's not that bad. So we need a few things. I'm just going to call this Sir X equal, and I'm going to put this at 450. Why not? Let circle Y equal, I'm going to put it kind of in the bottom, so I'll just say 450 again. Let circle diameter, there we are, equal, I'll make it about the same size, just 100 again. And I think that's all we need to start with. So let's go ahead and add the shape here. So I'll make it fill, and I'll make this pink. Yeah, why not? And then ellipse, circle X, circle Y, circle diameter, circle diameter. Boom, there is our circle. So, like I mentioned, the math is a little more complex in the sense of we don't have parallel sides in order to just very, very easily say, hey, if it's this plus this, it's a little more complex. What we have to do is determine whether or not our mouse is over the circle, but the circle has no sides to check. So to do that, we have to determine the distance between the center of the circle and our mouse. It's pretty straightforward, but we need to do a few things. We also need to have a circle radius, but we don't need to define it yet. I'm going to pull up actually a reference material as a way to talk about reference and pull up the distance function. This is a useful little tool. But basically, in order to do that, we just need to have two specific points, and we can determine the distance between that, between those 2 points. And that's what's going to be the key for the circle. So let's get into this. So we can say here, do a little bit of math. We can just say circle radius is equal to circle diameter divided by 2. So just remember the radius of the circle is the distance from the center to the edge. The diameter is the distance from the edge through the center to the opposite edge. So it's always going to be half of the diameter. The reason I'm calculating this in the draw loop is because if I want my circle to change size, now I don't have to go back into my code and change all the math. It just calculates it every time we loop. I'm going to slow this down, though, because I'm tired of looking at it go so fast. So I've got that right there. So I'm also going to just add another conditional inside of my nest here. But we aren't going to use it just yet. we need to figure out one more thing, and that's going to be the what I'm going to call the um, circle overlap. Actually, I'll keep it the same of sir. Um, the overlap is the mouse overlapping with the boundaries of the circle. So to calculate that, we can just say circle overlap gets assigned, and this is going to be the result of the distance function, and the 2 points we're going to give it are mouse x, mouse y. That's pretty easy, and then circle x and circle y. So again, we're just calculating the distance between the mouse, wherever the mouse is, and the center of the circle. Again, if you remember this, if this is the mouse right here, this will be the center of the circle. And we're just calculating that in pixels. And you can see how that just continually updates. We're essentially doing the same thing. Okay. So we've got that. And right now I'm still getting errors because I haven't actually typed my test here. What we're going to be testing, though, is the mouse within the circle? Because, well, this is just math and how it works. If the circle overlap is less than the circle radius, then we have to have our mouse has to be on the circle. Just like if the mouse position is bigger than the x but less than the x plus the width, it has to be in here. It also, if the distance between the center, if it's less, the distance between the center and the mouse is less than the distance between the center and the edge, the radius, then the mouse has to be overlapping with the circle. It's physically impossible for it to be anywhere else. So we can boop, boop, boop. I'm just going to copy this. And instead of lime green, let's make it... I didn't want to do that. I already used blue. I'm just looking around. What's the color next to me? Orange. There we go. So we can check and see. Nothing's happening as I click around the circle. As soon as I click in the circle, the background changes to orange. But again, as soon as I move outside, there we go. And just like with the rectangle, if I wanted to say right here, not ellipse, circle, I'm going to use y again, minus equal 5. That's not right. Oh, I got that backwards. All right. Cool. There we go. And I'll put this back at 5 again, just so they're moving at the same speed. And then I'm just going to copy this so the circle doesn't go away. If, yeah, come back. Circle Y is less than, let's see, the circle, negative circle R, which because I don't feel like doing the math right now. Then it's going to circle Y gets assigned height plus circle R. There we go. All right, so now I've got these two shapes that are moving, and they're just looping over and over again. I've got these conditionals here that, again, we're changing a variable, and then if that variable reaches a certain range, we're just going to set it to a new value. So now we've got this infinite loop going. So now if I just sit here and keep clicking my mouse, you'll see that as soon as it overlaps, there we go. I can change the size of my circle to be whatever I want. So maybe I wanted this to be 300. Same thing. Nothing, but as soon as I overlap, just because we're using variables for all of this, the math will automatically update and change to be whatever we want, whether the shape's bigger, smaller, whether it's moving in another direction, everything will update as we go. Maybe we wanted to make the rectangle really wide or really narrow. It's the math is there. You just have to change the variables. You don't have to change any of said math. Again, for this one, I just set the background to a different color. It's pretty boring. I'll just say it that way. I clicked on the shape, the background changed. But you can put whatever you want here. I just want to stress that out. You can put whatever you want right here. It can be any kind of interaction. I'm just doing that to show just really quickly the basic, results, the what happens. You put it there. So that's it for this video. This is just the basic, how to do this. This becomes a little more complicated if you start rotating shapes, or if you have like an oval or a triangle. It's definitely possible, but that's when assigning it directly to the shape via objects and classes and things like that, or utilizing a library where that's already done for you, makes your life a lot easier. And in fact, that's what we're going to be doing in this class a little bit later. I have a few videos from the last time I taught this up on YouTube if you want to check those out. Otherwise, there's plenty of resources that you're able to find that'll be useful for you. So that's going to be it for this video. After I'm done talking, I'm going to add some comments here just to label everything that happened, and I'm going to stick that into the description of the video, so you'll have all of the information right there. So that's going to be it for me, and I will see you all